concept that allows you to store many different values in a single variable, essentially. Arrays are common in most programming languages. They help simplify and make your program a lot more efficient. So we are going to talk about creating and using arrays in C. So an array, it's very common in a program to store many data values of a specified type. In a sports program, for example, you might want to store the scores of all the games or the score for each player. Up until this point, we could easily implement that, but we have to write a different variable for each score. So imagine if there is a ton of games. I mean, in baseball, there is 162 games. If we were to write a program that was a baseball program that wanted to store some stars or something, we would have to create 162 variables for each game to keep the score. Now, that is a pain in the butt. It would be very tedious and it's really just too much. So this is where array comes into play, and array will solve this problem. You don't have to create 162 variables. You can create a single variable and access it a certain way. So arrays allow you to group values together under a single name. You don't need to separate variables for each item of data. So it's going to allow you to become a much more efficient programmer. An array is a fixed number of data items. They are all the same type. So only one issue with an array is that you can't change the size of the array. Once you create the array, it's always going to be that size. And the other restriction is that you can't store multiple types of data. If you declare an array and it's still going to store numbers and ints, it has to store ints. So a couple limitations. How do you declare an array? Remember that when you declare a variable, what you are doing, you are saying that this variable exists in the program. And when you are declaring these primitive data types, you are all allocating memory form. When you declare an array, the data items in the array are referred to as elements. So this is another concept when you think of an array. If I'm saying the term element, that means I'm referring to an atom in the array. Because remember, an array is going to have many different values, but with the same name. And as we mentioned, the elements in the array have to be the same type. You can't mix and match data types. You can't have an array of 5 ints, 5 longs. There's no such thing as a single array of multiple data types. Declaring or use an array in a program is similar to a normal variable declaration. All you have to do is specify the name and then use brackets. So that's the only difference, this idea of square brackets following the name. Here's an example. This looks like a normal variable declaration, but what you see here is you have these brackets. That's the one thing that's not normal, and there's a number inside them. The number inside the brackets are specifying the size. So here we are just saying we are going to create an array named numbers of type long. That's going to contain 10 elements. So it's a straightforward. This is a number declaration because the semicolon is at the end. It's just like a variable declaration, but you have those brackets and a number, and this is the size of the array or the array dimensions. Once you have declared an array, you are then going to want to start using it. You are going to want to start accessing the data inside of it or writing data to it. In order to do that, you have to understand how the array is stored in memory and how it's actually going to be accessed. So an array with each of the elements in the array, each of the data items, they are accessed using the same name. So you are still going to access it with the variable name. However, if you want a specific value in that array, you are now going to have to use something called an index or a subscript. Both of these terms are used interchangeably. This index or subscript value is going to be a number, and it's going to be inside the bracket as well to access an element in the array or write to that spot in the array, write a value following the array name. So index value are sequential integers that start from 0. So when we talk about an array and its element, and we talk about the indexes in an array or the subscripts, all those subscripts can start from 0. This is basically saying that their arrays are 0 based, so index value for elements in an array of size 10 would be from 0 to 9. 0 is going to represent that first array elements, and 9 is going to refer to the last element in an array of size 10. So you have to understand this concept of 0 based array. Intuitively, you might think, oh, I want to access the first spot in the array. Okay, I provide index 1. No, because they start at 0. So it's very, very common to mistakenly try to access an array and be off by 1 because you think that they start at 1 and they don't start at 0. This is referred to as an off by 1 error. You can use a simple integer to explicitly reference the element that you want to access. For example, if you want to access the fourth value in an array, you would say the array name and then inside the brackets, you would say 3. So array name sub 3 is going to access the fourth value because the array name is 0 based. So you just have to provide a number for the element that you want to access. And again, remember that it's 0 base. So to access the fourth element, it's 3. If you want to access the eighth element, you do index 7. You can also specify an index for an array element by using expression. So you now only have to use a number. You can use an expression in square brackets following the name as well. However, the expression has to result in an integer value that correspond to one of the possible index values. So if you have an array of size 10 and you use an expression, that expression has to be valued to either 0, any number from 0 to 9. It's very common also when you are storing elements in an array to use a loop to access them. And we are going to throw an example of that as well. So for example, here we have a for loop and we are initializing our loop control variable to 0. And we are exciting once one is less than 10. And what we are doing here is we are just displaying the numbers in the array. And so we are saying printf number is %d and then numbers I is a variable. You can use a variable in a variable expression as long as that variable represent a number from 0 to 9. And in this case, it does. It's very common to use for loops to iterate over an array to either access the elements or write data to those elements. So to summarize, here's a nice little illustration that I found. This is how an array is structured. If I have an array called numbers, you are going to have the name of the array followed by brackets, which identify individual elements in the array. So I can declare an array by just specifying the type and the name, and then specify the size inside brackets. And then when I want to access it, I just use the array name followed by the index value. And so for an array that has a size 10, you are going to have indexes that are valid from 0 to 9. So what happens if you try to access an element in the array with an invalid index? For example, try to access an array of size 10 using 11 as an index of 10 as an index. You are doing have an array out of bounds error. So if you use an expression or a variable or a constant for an index value that is outside the range of the array, and outside of the array means what? Well, it means it's either a negative number or it's number that's greater than the size, really greater than the size minus 1, because there's 0 base. So if you have an array of size 10, size minus 1, if it's greater than 9, you are going to have an array out of bounds error. And the problem with an array of bounds error, it can cause your program to crash, or even worse, it can cause your program to look like it's acting normal, but then it doesn't act normal. So it doesn't produce consistent results. Sometimes you will have a garbage data that doesn't mean anything in the array. Again, it's very unpredictable when you have an array of bounds error. And the issue is that the array out of bounds error cannot be checked by the compiler, because the compiler is going to not going to know if you are assigning something greater or if you are accessing something greater than the size. It is still going to compile even though you have this area out of the bounds error. Essentially, the array of bounds error is a runtime error. You are not going to find out this error until you run the program. And again, it can cause your program to be very unpredictable. So you want to be very, very cognizant of how you are accessing the array, what index values you are using, and how you are writing data to the array with the index value. Pay very close attention to the array indexes and also the bounds. If you want to write data to an array, it's very, very simple. You are going to do basically just use the index. So a value can be stored in an array element simply by specifying the array element on the left hand side of the equal sign, and then using the brackets to specify the elements that you want to write to. So for in this example, we have an array named grades. We don't know what size it is. It's got to be bigger than 100, or else we had to have an array out of bounds error here. But in this example, we are saying grade sub 100 is equal to 95. The value 95 is stored in the element number 100 of the grades array. Very simple. You just specify the index and then whatever value you want to assign, you do. You can also use variables to assign values to an array. So 95 should be stored in a variable, just like you assign other variables. Now let's go through an example of using an array. Here's an example of using an array that is going to some read in 10 minutes. And then give me the average of those 10 numbers. As we are reading them and we are going to calculate the sum, then we are going to display the average. So at this point, I want to take this example and I want to put it in code blocks, and I try to run through and show you how it works. We are in our normal view. We are in a simple project, and we are going to show you how an array works in code blocks. You will notice that we are in our main function. This is the entry point to the program. And on the line 12, we are declaring an array. We are going to declare an array of type int of size 10. The size is inside the bracket. We end it with a semicolon. This is an array that's going to store 10 values. If we didn't have this array stored, what we had to have to do is we had to say grades1 int, grades2 int, grades3. You see how problematic that is and how very tedious it is. It's very nice that we can simply create a single variable that stores 10 times and they are grouped together. When you store items in an array, you don't want the values of the data to be different, all different things. Link in this example, we are storing grades, so they are all grades. You don't want to name an array something and then say I am going to store my grades. I'm going to store my whatever my age in there and anything. Make sure you store the same type of data when you are in it. The next variable in line 13 is a count variable. It's equal to 10. It's going to be the number of values to be read because we are going through the array. Sum is a long. We are going to sum the numbers as well. We go through the values and then average is going to be a float because we want to get the average of the numbers. First thing we are going to do on line 17 is we are going to tell the user that we want to them to enter 10 grades and then we are going to read in the values. So on line 20, you notice how I am indenting and I am using good naming, indent, and use good blocking of code for blocks of code indent. Here on line 20, I am declaring my loop control variable. I am running an older compiler, C compiler 89, so I can't declare it and initialize the same line. Normally, you would just do this, but when I do it again, because I am running C89 compiler, getting an error, So I declare my variable online 20 and then I use a for loop. We are familiar with for loops from our previous lectures, allows you to repeat code. Here we are just saying we are going to have a counter controlled for loop. We are going to start at 0 and we are going to go all the way until 10. So we are going to go through 10 iterations, but you notice the index is 0. That's important because we are going to be accessing an array using that variable I, and then you will notice in the end of the for loop, we modify the loop control variable by implementing it. So we are going to print out the value of I plus 1 as we go through the array to show you are at for the numbers. So it's going to basically say like enter grade 1, grade 2, grade 3, grade 4. It's then going to ask you to enter in the grades using scanf. We are going to store it in our array. You will notice that when you store it in the array, just like a normal variable, Excel, you just use grades and then you specify the index. Here we are using I as our index, so that's going to be equal to 0, the first iteration, 1, and the second iteration, 2, and the third iteration. And it's good we start with 0 because arrays are 0 based, and then we just use the address of the operator, the ampersand. As we are going through, we are going to sum the grades together. So we are going to say sum equals sum plus grade sub I. Each grade is going to basically calculate the total. And then once we get out of the loop, after running 10 times, we are going to set our average equal to the sum divided by the count and cast to a float. We are casting here. This is changing the data type. Remember, sum divided by count, sum is it long and count is an int, and we want to cast that to a float. And then at the very end, we are going to print out the average. So let's go ahead and run this and make sure we get no errors, which we have 0 error and 0 1. So now let's run it. And so it's going to do exactly what I mentioned. It's going to say enter the 10 grades and then it puts a 1 in a little mark. There is so we know what number we are at. It's going to put in like a 95, 32, 55. It's going to go in and just put any number in here. They don't make sense necessarily. That's okay. And my last number 23. The average of those 10 grades is going to be 51.20. But it's really nice because we don't have to create 10 variables. We access the array using the subscript and we can assign values to the array using the subscript. This is actually assigning when we do the scanf. We are assigning data to that subscript. Now, if we wanted to change this and say we started at 1 and instead of going to count which is 10, we actually set it equal. So actually, let's not change that to 1. Let's say we are going to start at 0, but now we are going to go all the way to index 10. Remember, index 10 is out of bounds because the size of the array is 10, but the index value 0 based so that the max index is 9. And again, we are going to be able to compile this because compilers do not detect out of bounds error. The problem is when we run it. Now, when we run the program, we are going to have a big problem. We try to enter in 11th grade. So we are going to be all good when we enter 10 grades, and the problem is going to happen when we get to 11. Now we have 11 and we are going to try to store that. It's nothing bad happened, but our average is not going to be correct. And it's very unpredictable behavior when you have an out of bounds error. So you want to make sure that you have the I lesson account, and you want to make sure that when you access the information, you don't go out of bounds as well. And this is the basics of the array, declaring the array, specifying the size, just data type, and then the size and brackets accessing the array, or storing data in the array, assigning values. using the subscript I inside the indexes. And we could even print out the indexes using subscript as well. Arrays are going to be used quite a bit. We are going to have many examples with arrays because it simplifies things. Just remember, arrays are fixed size. You can't change the size of the grids. It's always going to be 10 as you run the program. So if you assign any data above that, it's not going to expand. And also remember that grades have to be the same data type. I can't store strings or words in grade. We know how to use an array. We know how to create an array, but specifically what if you want to assign a specific initial values to the array? How do you do that? So you will want to assign initial values for the elements of your array most of the time. The reason that you want to assign initial values to an array or even to a variables is because it makes it easier to detect when things are going wrong. When you don't have initial data and you try to do something, you can cause problems in your program. So initialization is a very good thing and you always want to do it. And using an array, there's many elements in an array. So there's a specific way that you can initialize those elements. There's different syntax that you can use, but initialization is a good thing and you always want to do it. I wanted to quickly talk how you can do an array because there's different way to do it. So just as you can assign initial values to variables when they are declared, you can also assign initial values to an array elements when it is declared. To initialize an array's values, you simply provide the value in a list. The list is separated by commas and the entire list is enclosed inside a pair of curly braces. It looks something like this. Here we are creating an array named counters. It's of type int. It has 5 elements. And then what we are doing is we have the curly brackets and we are not using any indexes in here. You will notice that we just have numbers separated by commas. What this is doing is it's setting all 5 elements in the counters array to 0. Each of the elements are 0. If we have another array and we name this array integers and it's also of size 5, and then we have in our curly braces after the assignment operator 0, 1, 2, 3, 4, what that is doing, it's assigning integer the first element integers array to 0, the second element to 1, the third element to 2, the fourth elements to 3, and the fifth elements to 4. It's a nice syntax where you can immediately initialize the array. When you declare it by just providing numbers separated by commas inside brackets and you want to do this, it's also not necessary to completely initialize the entire array. So in those two previous examples, we initialized all 5 elements of an array of size 5. What if you only want to initialize some of the values? If you provide initial values that are not equal to the number, the size of the array, then the remaining values are set to 0. So if you do something like this, where you have an array called sample data of type flow, it contains 500 elements. But in the curly braces, all you see here is our 3 elements. What this is going to do, it's going to initialize the first 3 values of the sample data array to 100, 300, 500, and 5. Then the remaining 497 elements are going to be 0. So you don't have to specify everything. There is also this concept of a designated initializer. This was introduced, I believe, in C99. It's a nice little feature where you can pick and choose your elements that you want to initialize. I think in C99, they added it, and then in C11, they made it optional. So depending on what compiler you have, you may or may not be able to do this. But I want to mention it because it's somewhat common. Some compilers will not allow you to do this after C99 version, but it's cool because you can actually just pick and choose. So you can choose enclose an element numbers in a pair of brackets and specify the array element that can be initialized, and you can do it in any order. So here's an example. Again, we have our sample data array of type float. It's going to be 500 inside, but here inside of our curly braces, we have additional indexes. We have our brackets in 2, says brackets to sub 2 equals 500.5 and sub 1 equals 300.0. And so 0 equals 100.0. They are separated by commas. All this is doing is it is specifying the same thing that we had in the previous example, but it's doing it in a different order. But you are still going to have element 0 or the first element equal to 100, the second element equal to 300, and the third element equal to 500.5. But we are specifying the what index to initialize right in the curly bracket. Another example here we have an int array called ARR. It's of size 6. And when we declare it, we are initializing the fifth element, which is the last element to 212. All the elements are going to be 0. So here is an example of traditional initialization where you just declare the name of your array and you supply many different numbers. In this example, we are declaring an array and it's going to store all the days in every single month. And so when we go through this array and we print it out, which is very common, you typically use loops to print out elements in array or at least iterate over them. What we are doing here is we are just going to print out each month and how many days it has. So let's go through this in code blocks to show you the output. So here's our example. We have days and months and we are initializing the array. The first element to be 31, next 28, and next 31. You also notice up on line 10, we are using define to create a constant. And by the way, in C, you can also use a constant keyword, which we will talk about, and other things. That's another way to create constant. But right now we are just talking about arrays and initializing them. Very easy to do, separated by commas inside curly braces. So what this is going to display is it going to then days index. So it's going to say month 1 has how many days depending on what the values are. So we are accessing the index by the array name and then the subscript value, the index value, and we are using an array. So it's a variable that changes through each iteration. So we try to run this. The output that you are going to see is month 1 has 31 days, month 2 has 28 days, kind of represents January, February, March, April, but it just goes through the array and prints the days out. So this proves that the initialization works. And again, you will want to initialize your data. Now let's talk about another example and talk about repeating initialization element. So here would be another example, but in this example, we are going to use a designated initializer. We are going to specify the exact elements that we want to initialize. So the main line that you should notice in here is the one that says into days and months, where we are doing our initialization. You will notice inside the curly brackets that the first element gets 31, second 28, but then there's something inside bracket that says 4. It's going to get value 31. Then we have a comma. Element 5 is going to get 30. Element 6 is going to get 31. And then we have 1. This means we are now going to override the 28 and we are actually going to put 29, put it as 29. So it's a kind of redundant here. We don't really need to do that, but you would really remove the first index because 31, 28 subject 1 is already assigned here, but it looks like we are saying index 1 can also be value 29. So this is just using the designated initializer. What about if we want to repeat the same value? Now in C, you can always initialize the entire array of the same value if you specify 0. You can always initialize it's like the null parameter. But other than that, C doesn't provide any shortcut mechanism. For initializing array elements, at least not in C89, you may see in C11 again, where you can initialize the same values to the entire array, just using the bracket with no subscript, just the number. But right now in C89 and C99, there is no way to specify a repeat count. There is no way to say all the elements of this array should be 55. For example, so if it were desired initially set all 500 values of the sample data to 1, all 500 would have to be explicitly assigned, which would be a big pain in the butt. So what you will need end up doing is you will just put them inside of a loop. Easiest way to iterate through an array uses a loop. Here's a quick example of how you can initialize all the elements to the same value. In this case, though, we are initializing the first elements to 0, 1, 4, 9, and 16. So this is really just initializing all the remaining elements to a value. Essentially, the sixth element of the 10th element using index 5 to 9. So that's what this for loop is doing. The first for loop is saying that we are going to initialize elements from 5 to 9 to be y times 9. And then the second for loop here, it should be indented. It's harder to read. The second for loop is actually going through the entire array and just displaying the data to show you that the last 5 values were actually initialized. So whenever you want to repeat the same value or initialize to different value, just use a loop. Again, initialization is important. You will want to initialize, so make sure that the syntax is second. Until this point, if you are thought of an array, you just said an array is a variable that can store many types of data. It can get more complicated than that. You can have basically many dimensions of an array. So if you just have a linear array, which is what we have discussed so far, that's called a single dimension. And we know it's a single dimension because it just has a one bracket with one size. The C language allows arrays of any dimension to be fine. So this is kind of thought of like a nested array, an array of an array. So two-dimensional arrays are the most common, but you can actually do three-dimensional arrays, four-dimensional arrays, five-dimensional arrays, but there is not many use cases for 3, 4, and 5. Really, you are either going to have a single dimensional array that you use in your program or two-dimensional array. Two-dimensional arrays are common because they essentially represent rows and columns in a spreadsheet. That's how you can kind of visualize it, or a matrix or a table. That's a two-dimensional array. You have rows and you have columns. So you can store more data than a single dimension array by specifying the sizes. But it is very applicable because it looks like a matrix. And these are applications that you may want to write that has this concept of a matrix. Specifically, a mathematical application would be most relevant here. But you can use to do two-dimensional arrays for many different things. One example is a matrix. But again, visualize it as a table. Two-dimensional arrays are declared the same way that a one-dimensional array is. The only difference is you now have another set of brackets. So in this example, we are declaring an array named matrix of type int, which has 4 rows and 5 columns. That means you can store 20 elements inside that two-dimensional array. So you should know how each dimension is specified with its own pair of square brackets. That's how you can easily spot how many dimensions an array has. If you had 3 brackets there, that would be a three-dimensional array. If you have 4, it would be 4. This one has 2, so it's 2. And up until the earlier lectures only had 1, so we knew that was a single dimension. So look at the bracket, pay attention to that. Again, 4 rows, 5 columns, total of 20 elements. To initialize a two-dimensional array, it's going to be initialized in the same manner of a one-dimensional array. Say type of syntax, you are just going to add more. So when you list the elements for initialization, the values are going to be listed by row. And the difference here is that when you put the initial values for each row, you are going to do it between braces, curly brackets. And then you are going to enclose all the rows between braces. So it's going to look something like this. If we create an array of numbers, which is of 2 dimensions, 3 rows and 4 columns, and we want to initialize it, all you have to do is put inside a curly bracket the entire array and the add inner nested curly bracket for each row. So here we are initializing values 0, sub-0, index to 10, index 1 to 20, or index 2 to 30, or index 0, index 3 to 40. And that's how you access multi-dimensional arrays too. You access them with the row in the column. You just have to remember that it's zero based. So the upper left hand, which would be now one column, would be 0, 0, and that would be equal to 10. Row 1, column 2 would be equal to 0, but you would access it as number 0, index 1. Because the first array contains 3 rows, you access it, that's the number. You specify for the row number, and then the column number is the next specification for accessing the array. But individualization is pretty simple. Just separate things by comments with the brackets and accessing them. You would access it just like you access a normal array. Except you are accessing this concept of a row in a column. So the use of the inner pairs of braces is actually optional, but you should use it for readability. If you didn't provide those braces, you could actually just provide 10, 20, 30, 40, 15, 25, 35, all just consecutively, but it's very hard to visualize what you are initializing. As a programmer, readability is very, very important because it increases the quality of the code. It's easier to maintain the code. When I look at this right here, I can easily identify, especially with the comments, what I am initializing to what values and what rows are going to initialize to. If I had that as a single line, just consecutive numbers, I would get lost really quick. So although the inner brackets are not necessary, use them. As with a one-dimensional array, it's not required to have the entire array be initialized. So you can just initialize certain areas. So in this example, we are creating two-dimensional array with 4 rows and 5 columns. We are only initializing the first 3 elements of each row. So row 1, column 1 is 10, row 1, column 2 is 5, and row 1, column 3 is a negative 3, and the same for the second column, and so forth. For the ones that we didn't set the fourth and automatically because we left them out, and in this case, you actually have to provide the curly braces, the inner ones, because there, if we did it, the initialization would be all screwed up. Because if you didn't have the curly braces, it would just do it consecutively. So what would happen is this would actually initialize the first 12 elements. So it would initialize all the elements in the first row, all the elements in the second row, and then the first 2 elements in the third row, and then the rest of the elements in the third row, the rest of the elements in the fourth row would be 0. Again, this is a two-dimensional array of 4 rows and 5 columns. It would just do them consecutively. Don't forget the braces if you only want to specify certain initialization elements. You can also do designated initializers. Remember, this is the C99 concept that's optional in C11, where you can specify specific indices to be initialized. So you can use subscripts in the initialization list, just like in a single dimensional array. If you want to do a designated initializer, you would just do something like this. So here we are declaring our matrix array of 4 rows and 3 columns, but we actually specifying that 0, 0 is equal to 1, 11 is equal to 5, 1 is equal to 5, 1, 1, 2, 2 is equal to 9. So when we say 2, 2 again, what we are saying is row 2 is which is really row 3 because we start at 0, column 2 which is really column 3. Again, visualize this as a table or a spreadsheet, and accessing the elements start at the top left hand corner. But if you understand that the 4 represent the rows and the 3 represent the columns, it's pretty intuitive after that. So what this is doing is it's initializing the 3 indicated elements of the matrix to specified values. But what you should notice here is the syntax. All the unspecified values here are going to be 0 by default. This is only going to initialize 3 values. Each set of the values that you do initialize are going to be the elements in a row is between the braces, and then the entire initialization goes between another pair of braces. So you see that we have the curly brackets on the outer one, just like normal initialization, and then we have the brackets to access the array inside. And then we have commas to separate each row, and each set of row values is separated from the next set by a comma. So the values are separated and also the row indices. Now just because we said that we have 2 dimensions and we have been talking about that, you can actually have many other dimensions. Everything I have talked about with 2 dimensions also applies to 3 dimensions, 4 dimensions, 5 dimensions. So if you wanted to declare a 3-dimensional array, you would do it with the 3 square brackets. So here's an array named box of type int of 10, 20, 30. You might want to use a 3-dimensional array. Maybe if you were storing XYZ values of some sort, you probably would not need to do this. 3-dimensional arrays and are really not common. As a summary, you can visualize a 1-dimensional array as a row of data, single row, 2-dimensional array as a table, a matrix or spreadsheet. In a 3-dimensional array, you can visualize as a stack of data tables or a stack of tables. If you needed that much data, it's going to be really hard to access it and probably confusing. And anybody that's maintaining the program for a 3-dimension array or ever, it's probably going to get lost trying to figure out what's going on, what you can do it again, and if you are ever going to need to iterate through any of these 1, 2, 3-dimensional arrays, you are probably going to use a loop, and the more dimensions you have in that loop, the more nested loop you are going to have. So if you wanted to process a 3-dimensional array, you are going to have 3 nested loops. And if you want to process a 4-dimensional array, you are going to have 4 nested loops. So as far as initializing an array that's higher than 2 dimensions, again, you are going to apply the same type of thing. You are just going to extend it a bit. So a 3-dimensional array will have 3 levels of nested braces with the inner level containing a set of initializing values for each row. So it would look like something like this. Here we have a 3-dimensional array, 2, 3, and 4, a stack of data tables essentially. And the first block of 3 rows we are going to initialize, and the second block of 3 rows we are going to initialize. So what this is saying is again first block and second block. Because we didn't initialize the third and the fourth block, just the first and the second. So we have 4 blocks, and you can think of as each block a stack of data tables, each block having rows and columns. So the first block is going to be initializing just the first 3 rows, which is all we have is 3 rows. And then second block is going to initialize the next 3 rows, but the third and the fourth blocks are not going to be initialized. If you want to initialize the third and the fourth blocks, you have more inner braces, curly brackets, and so forth. Same thing applies for the one that you do not initialize. They will be initialized to 0. But again, you can see how it gets very tedious and also very hard to follow when you want to process the elements in a dimensional array. I mentioned you are going to use nested loops to dimensional array. Again, it's going to correspond directly to the number of dimensions, and each loop is going to iterate over one array dimension. So it's going to look something like this. This is an example of 3-dimensional array. You have an outer loop, and then you have 2 inner loops. You have an outer loop, and then you have 2 inner loops. Okay, outer loop going to be the first outer array. So the outer loop would essentially go through the rows, and the second one will go through the columns, and the third one will go through the blocks. Again, what you should be noticing is, wow, that gets really hairy and really tedious really fast. I try to avoid 3-dimensional, 4-dimensional arrays. I don't even see many use cases for it. One and two are really odd you are going to use. But understand multidimensional arrays are a possibility in C, a way of storing more data and accessing the same name with many data elements. Thank you. You have to get enough knowledge by doing that challenge of array. I want you to get familiar with how to use an array, how to access an array, and how to create an array. So you should write a C program that's going to find all the prime numbers from 3 to 100, and we are going to do it very efficiently. So we are going to use a little algorithm that makes you use an array, but a very simple program. It's just going to display as output all the prime number from 3 to 100. And the reason you don't do 0 to 3 is because you are going to hard code those pretty simple. First two prime numbers are 1 and 2 that are non-zero. So there is going to be no input to this program, just output. And the output is going to be each prime number separated by a space on a single line. It's pretty basic. All the way up to 100, you are going to need to create an array that will store each prime number as it is generated. You can hard code the first two prime numbers, which are 2 and 3 in the prime arrays. So what I would envision here is that you would create an array, you would name it primes, and you would just hard code the first two in there. And it's important to hard code them too, because the algorithm that we are going to use to find prime numbers is going to compare for any other prime numbers. And I will explain that in a second. We want to utilize the loops for this assignment to only find the prime numbers up to 100. So right off the bat, you should envision a loop at least to display the prime numbers that you found. So that would probably be the ending loop, the loop at the end of your program that just goes through the primes array and displays everything that's inside there. Now, if you are finding all the prime number up to 100, you are not going to need make the size of the array probably more than 50, because I don't think there is more than 50 prime numbers all the way up to 100. But you are not going to be able to see it exactly correctly because you don't know how many prime numbers are there. So I would say when you create the prime array, just make a size of 100. So you definitely need a loop to print them out at the end. You are going to need another loop to try to find the prime numbers. And you can find the prime numbers any algorithm you want. But what I would use is I would use something like this, because there's some reason to use an array if you do this algorithm. So the criteria that can be used to identify a prime number is that a number is considered prime if it is not evenly divisible by any other previous prime numbers. And there's also more to that algorithm, but there's the starting point. You also want to only look up to a certain numbers. So you can use the following then X condition in the innermost loop. So again, there what they are going to need to have here is you are probably going to need to have two loops. We already mentioned the third loop at the bottom printing out the data, but you are going to need to have two loops for this assignment. And the algorithm that I am discussing here is a more improved algorithm. This is why you want to do it. Now, if you want to find prime numbers in a different way, that's okay. As long as you can use an array, because the whole purpose of assignments is not to understand prime numbers, it's to understand how to use arrays. By looking at the previously generated prime numbers, that forces you to use an array, and you had a store that each prime numbers as it gets generated, as I mentioned. The other way that you can make it even more optimal is that you don't want to look at even numbers. So if you are going through each number from 3 to 100 and you are checking if that's prime, you can ignore the even numbers, because even numbers are never going to be prime. So in the outermost loop or the innermost loop, you can check to see if the prime is divisible by other prime, or make sure it's not even. You can check that and skip it. And then this other access condition in the innermost loop is to make sure that the value of the p does not exceed the square root of the primes. That's the other part of the algorithm. So this might not make full sense, but basically these are some of the criteria that I want you to follow. Skip any checks for even numbers, and then the algorithm is to look for any previous prime numbers that were generated, and also to check whether or not p does not exceed the square root of the prime numbers, because that's another way to check for a prime number. So you are going to need to have a for loop which basically goes from 5 to 100, and then you can increment that by 2 so that you only look for odd numbers. And then in an inner for loop you have inside there, you are going to want to go from 1 until this other values p divided by prime index I is greater than equal to prime index I. And you will probably also want to make sure that the number is not prime. So you don't want to exceed a certain check, and then you also want to jump out of the inner loop if you actually found a prime number. If your current number is divisible by any previous number, so you can look at the prime numbers, prime array. And if the modulus for that is equal to 0, then you don't have a prime number. Otherwise, if you have done this whole check in this entire loop and you have got out of this there with already exceeding the prime I is greater than prime index I, the square root issue, and you not actually found a prime number, then that means that you can then add that prime number to your prime array and then just print out the array prime arrays. So the actual algorithm does not seem as confusing as I'm making it. Again, try to give you as many pseudocode hints there as possible with the outer for loop in the inner for loop, but you are going to need to access arrays, you are going to read arrays, you are going to look at array to see previous values. It's going to get you familiar with arrays. So good luck, and I provide okay. Up next, going this challenge, this assignment is going to deal with multi-dimensional arrays. Get a little more familiar with that, mainly a 2D array, as it is something that you should understand. So in this challenge, you are going to create a C program that uses a two-dimensional array and a weather program. This program will find the total rainfall for each year, the average early rainfall, and the average rainfall for each month. So those three things are going to be output. The input is going to be a two-dimensional array with hard-coded values for rainfall amounts for the first 5 years. So what this means is you should create a 2D array that has 5 rows and 12 columns. The rows are going to represent the past 5 years, and then the columns are going to represent the months. So how much rain you got in January, February, March, April for each year, and the rainfall amounts should be floating point numbers. Because you often get 7.8 inches for rain for month, they are going to need to be floating point. When you create that this two-dimensional array, make sure that it's a float. The output for the program is going to look something like this. Here I just formatted it a certain way, but what you should first display as output is everything that's in the 2D array. So you should have just a simple loop that goes through the 2D array, displays the year for the array, and the year is just going to be whether it's the first row, the second row, and the third row. You can just create an integer and increment it, and then the rainfall is going to be all of the rainfall for all the months. So you have to add them as you go. So what you should first do is you should actually have a for loop and an inner for loop and go through it to calculate the total rain for each year, and then have a loop to print it out. And also in that first loop, or actually you probably want to create months for each year and calculates the monthly average. So again, the way that I envision the design for this program is 2D array floating point numbers. You are going to need to initialize it with all hard-coded data. You are going to have a first loop which is going to go through, and it's going to calculate the totals for the entire year. And then it's easy to get the early yearly average because you just take the total and divided it by the number of years, which is 5. So the early average you don't have to calculate in a loop, but you will need to calculate the total rainfalls. for each year in the loop. And so I would have a loop. You are going to have an inner loop, because every dimensional array you have to have an inner loop. Two dimensional have one inner loop. So an outer loop and inner loop, a nested loop, I should say. And you go through your first array. Your, you start at the year. So let me go through my tips. Actually, I think put this in the tips, but this is the output. You can format it anywhere you want. But what I am seeing here again is yearly rainfall, yearly average, and then monthly average. Then, so you want to initialize your 2D array with hard-coded rainfall months. We know how to initialize an array. For a 2D array, you can initialize rows. So you can have brackets inside of the brackets to represent each row, and each row has 12 columns, as you would have 12 values, 12 floating point values. And then you separate each row by commas, and you just create any brackets. You should know how to do that. And then again, just a reminder to iterate through a two-dimensional array. You are going to have a nested loop, basically one inner loop. If it was 3D array, you had to have two inner loops. The key to this solution will be visualize a 2D array and understand how to iterate through one nested loops. And if you know how to iterate through a nested array or a 2D array, you are going to be fine. As you are iterating, you can keep a running total, which is our first set of loops. An outer loop will iterate by the year in the inner loop, or iterate by the month, and you can keep a running total to get the total rainfall for all years. So you first goal should get you to just get that total rainfall for all years. And as you are getting the total rainfall, you can just print out the yearly total as well. Then after you are out that loop, you can print out the early average. Then you are going to need another loop to display the monthly average. And to display the monthly average, has outer loop for each month, and the inner loop goes through each year. I think this will give you a monthly average. So the yearly ones can be in that first loop, and the monthly will be in the second. So that's should say to get them to get the monthly average rainfalls. So you are going to learn all about initializing array. You are going to understand how to iterate through a two-dimensional array. A lot of important concept here. Good luck and provide these solutions.